Here's a solution key for our Rates and Equations quiz study guide. With our first problem, we're giving the velocity of a particle that's moving along the x-axis. And that velocity is 4 minus 6t squared. We're also given an initial condition. We know that the position of the particle is 7 units to the right of the origin when t is equal to 1, and we're asked to find the position of the particle when t is equal to 2. All right, so we want x of 2. Now we know x of 2 is going to be equal to our initial condition plus all the change in velocity from the point that we know until the point that we're interested in. All right, so we're interested in t equals 1. We're interested in t equals 2. We know t equals 1, so those are our bounds, 1 and 2. All right, so we need to solve this definite integral, which is going to be the integral from 1 to 2 of our velocity function, which is 4 minus 6t squared dt. And we're going to add to that our value at x of 1, which is 7. This is going to be our answer right here. X of 2 is equal to that value. Once we solve this, then we have our solution. So we have to solve this definite integral and then add 7. Solving the definite integral means we perform the fundamental theorem of calculus. All right, so we're going to have 7 plus, and then we do the antiderivative. So 4 antiderives to 4t, and 6t squared antiderives to 6t cubed over 3, or 2t cubed. So we have 4t plus 2t cubed being evaluated from 1 to 2. The 7 is not part of that. That ultimately won't make a difference, but we have it off to the side. So we are looking at 7 plus, and then we have 4 times 2, or 8 plus, and then 2 times 2 cubed. 2 cubed is 8, doubled to 16, so 8 plus 6, oops, that should be a minus sign. Almost close. So 8 minus 16, there we go. And then we're going to subtract from that. Now we're going to plug in 1. 4 minus 2. All right, so 8 minus 16 is negative 8. So we have 7 minus 8. And then 4 minus 2 is 2. And so we're going to subtract 2. So we have 7 minus 8, which is negative 1, minus 2 more, which is negative 3. Number 2 is basically the same problem. All right, we're given velocity. We want to find the position at t equals 3 if we know the position at t equals 0. All right, so our position at t equals 3 will be our position at t equals 0, because that's what we know right here, plus all the change in the velocity, all the change in the derivative of position from 0 to 3. All right, so x of 0 is negative 2. And then we're going to do plus the integral from 0 to 3 of 3t squared minus 4. Okay. So 3t squared becomes t cubed. 4 becomes 4t. That's being evaluated from 0 to 3. And then we're adding negative 2 to that. When we plug in 3, we have 3 cubed. And minus 4 times 3. When we plug in 0, we get 0 in both cases. 3 squared is 9. 4 times 3 is 12, so we have 9 minus 12. That should be 3 cubed. My bad, 3 cubed. So this is actually not 9, this is 27. All right, so we have 27 minus 12, which is 15, and negative 2 plus 15 gives us 13. Our answer is A. All right, next up we have problem number 3. A particle moves along the x-axis again. All right, this time our velocity involves trigonometry. So we're going to be looking at some stuff with our trig chart. We're interested in the particle's position at time t equals 0. So x of 0 is equal to x of our initial condition, and we know to be at t equals pi over 2. Plus the integral from what we know, pi over 2, to what we're trying to find, 0, of our velocity function. All right, now, x of pi over 2, we're told, is 4. So we have 4 plus the integral from pi over 2 to 0 of sine of 2t dt. Okay, got a couple challenges here. First of all, our bounds are backwards. 0 is smaller than pi over 2. All right, so we're going to change this to 4 minus the integral from 0 to pi over 2. The other challenge we have here is we have sine and we have an inner function that's more than just t. All right, so what we're looking at here is basically something like u is equal to 2t and du is equal to 2 dt. All right, we need a 2 here, which we don't have, so we have to put a 2 in, and we have to put a 1/2 out front. Okay, and what that allows us to do basically is now we can make the antiderivative without having any issues that we would have had before, because we had the 2t here with the corresponding coefficient missing. So we have that going on. All right. Now we can change over to u if you'd like. That's what we've been doing in class so far. So basically what's happening here is we have 4 minus 1/2, and then we're going to have sine u du. We also have to change our bounds. When we plug in 0, we get 0. When we plug in pi over 2, we get pi. And now we can take our antiderivative. So we have 4 minus 1/2. And then the antiderivative of sine is negative cosine. So actually it's going to be plus 1/2 cosine of u, being evaluated from 0 to pi. All right, so we have 4 plus 1/2, the cosine of pi, minus 1/2, the cosine of 0. Cosine of pi is negative 1, so this becomes 4 minus 1/2. And the cosine of 0 is 1, so minus another half. So 4 minus 1/2 minus 1/2, that's 3. And last but not least on this page, a graphing calculator problem. We're now given the acceleration, and we're given an initial condition, and we want to find the velocity of the particle at a certain point. All right, so v of 3 is going to be v of 0, because we're told what the velocity is when t is 0, plus the integral from what we know, 0, to what we're trying to find, 3, of the derivative of velocity. And the derivative of velocity is acceleration. So there's our formula for getting our solution. We'll let the calculator do all the work here, because this is a pretty complicated function. We also see that all of our answers have 3 decimals, so we're looking to let the calculator do the work. So I'm going to bring that in now. All right, so there's our acceleration function. We go right up here, also in at y1. So we're going to go back to the main screen. We want v of 0, which is 5. So 5 plus, and then the integral, so that's math 9. Our low bound is 0, our upper bound is 3, and our acceleration function is located in y1. All right, so we have y1 dx, and when we hit enter, after thinking for a little while, we see 11.710, which matches with answer E. So we'll select that one, and the first page is done.